Hello, everyone. My name is Badr. I work for a kitchen manufacturing company called Rondel Kitchens. I've been using LLMs since 2019. I've been using ChatGPT, and yeah. So AI got me promoted. Yes, you heard it correctly. AI got me promoted, and not because it wrote better emails, but because it found a very critical bug in the production database. But before I tell you my story, I have a quick challenge for you. Please, everyone stand up. I want everyone to stand up. Please stand up. We only have 6 minutes. Please, please. I beg. Okay. Please stand up and sit down if you hear your level. If you think you are that level, please sit down. Please don't sit down at level 1 or I'll hate you. Okay? So, yeah, 20 seconds. So basically, level 1, you don't use AI at all. You're a boring person. You write your own emails. You read your own reports. Okay, can I see anyone? Yeah, that's good. That's good. Okay. No one is level 1. That's good. Such a relief. Level number 2. Please, level number 2. Level number 2 is basically AI assistant. You might use your ChatGPT, Gemini, Copilot sometime. Okay, I can see one person sat down. So you don't use it very often, maybe once a week, okay? That's your level 2. Level 3, okay, level 3, you use it on your daily basis, okay? You use your ChatGPT. Yeah, I can see a lot of people gonna sit down. Okay, that's good. I was a level 3 before. But yeah, it can summarize, it can write your notes for you. But if you're a level 4, that's where it gets very complicated. Level 4 is AI workflow. Now the AI can read the ticket, and not only read the ticket, but it can understand what's the issue and it can assign it to the right department. Anyone level 4? Okay, good. Okay, I can see some few people. Okay. Level 5. Can I see level 5? Yeah, level 5 now. You gaslight your AI. You give it, please make this code look better and I'll give you $5. But anyways, it can now read the issue and it can also read the data. It's very risky, alert, alert, but that's level 5. Level 6, the company doesn't give you much money. So level 6 is basically you wrote an AI that can read the tasks, read the data, but also takes action. It can also replies. That's your level 6. Good. Level 7. Please go outside. So level 7 is AI orchestration. Now you have your LLMs that can understand each other's through either Kubernetes or open source or hosted locally. But if you're level 7, salute to you. But random applause to everyone, okay? Except level 1. But yeah, I was a level 2 and I climbed my way to level 6. I attended a bunch of conferences. I went to Google and I started to use some AI workflows, and one of them actually paid off. So I've written some AI workflows for our company, and one of them came with a very, very critical bug. I thought it was hallucinating at first because it was a Friday and I was hallucinating, but it wasn't hallucinating. It was actually right. So I have had a look at the code. So the other slide would say, yes, it wasn't hallucinating, it was right. But I'm going to explain how it found the issue, and I'll try to explain it because it's going to be SQL. Anyone familiar with SQL? Okay, a bunch of you. That's good. So it will. I'm going to show you the bug, and I'll show you how it found it and how it actually fixed it. So you will see on the screen and before and after. So before, this is the bug, and after, this is how it was fixed. It was just a bracket. Yes, people, it was a bracket, and it almost costed the company a bunch of grants. But before, you can see we have some order reference numbers for some specific customers, and we give them discounts. So we have to check the reference number and we have to check also the company. But the problem with this is, of course, but the problem with that slide is it only applied for the first customer, but the other customers, it didn't matter. It applied the discount anyways. But yes, I spoke to my manager. We found who did that problem. No, it wasn't me. It was the AI. I'm joking. It was a developer. The issue was he had to close the ticket and he forgot a bracket. But the problem is, part is usually not the model, it's the problem. You have to understand what are you trying to solve? What's the problem you're trying to fix? And we had a problem for our company with the design. We needed to buy a new software to get better design. I spoke to some of you yesterday and today, but I'll show you the before and after. So I was like, we can keep the old design software, but we can just take some renders, apply some AI, and we can make them look even better. And that's how we use AI in our company. So we use Gen AI and we gave that to marketing, and I kid you not, that increased our sales by 15%. Crazy. But yes, my takeaway is you don't need to reach level 7. I'm not a level 7. You just need to climb one level from where you sat down. Thank you very much. My name is Badr.
Hi, my name is Diego. I'll be co-presenting this with Oliver. We work at Sage. It's a Newcastle kind of based company, and we'll be walking through how we're moving POCs into AI POCs into production, which I guess is the theme of our conference today. Okay, so Nexus is a branding or kind of a platform that was developed in-house. I think the key components of the platform is that it's multi-team, so we are onboarding developers as well as centrally kind of governed within IT. And the key components are evaluation, access control, and reusable patterns. We get teams to move that excitement about AI to move into a production discipline through these loops: value discovery, prototype, pilot, and scale and optimize. Within each of the loops, we have value checkpoints to make sure that the idea still contains that value that's required.
Hello. So loop 0, our numerically contentious starting point, is to making sure that we're solving the right problem with value discovery. So before any build starts, we make sure that we have a defined business problem. We've got the right hypothesis and strategic fit and safe data path. Loop 1 is where we prototype. So very quickly within approved guardrails, the goal is not perfection here. It's about proven feasibility and exposing risk. This is also where any AI approvals come into the equation. And loop 2, it's going very fast. This is where the idea meets our real users within the enterprise. So we move from control prototype to focused pilot here. Real data, defined user groups, and clear success measures. And this is where we start thinking about that broader production rollout for the business.
And of course, loop 3 is where we're not asking the question, is it working? We're making sure that we are evaluating that use case that's in production with live performance dashboards, feedback logs, and of course, a value realization, which was our initial loop. Is it delivering the value that we thought was going to deliver? So we have 3 layers within Nexus. So we have the experience, the control plane, and AI data plane. So this is to consolidate what the user experience is like and how developers are working within the platform, as well as the infrastructure and the data feeding into the different use cases. And this is controlled by our team. The backbone of Nexus is a compilation of AWS services. Of course, we have identity for authorization and authentication of users, compute, of course, AI runtime as well. I think the key component of this slide is to how these different kind of boxes interact with each other, which makes Nexus a platform that is
monitoring. Obviously, super critical because agents behave very differently to the systems that we're used to. So this is where we need to understand the full conversation history. Obviously, going back to the talk earlier around the guardrails, super important. We need that audit trail to make sure we know what answers the agent's given and what's behind that. Evaluation is something that we do built in from the start. It's not something that we can do after launch. It is a promotion gate to anything that moves through Nexus. And the admin panel that we have is about putting access ownership with accountable teams. The use case team defines any scope, data, users, and owner. We've got attribute-based access on the platform, and visibility is not open by default.
Now, very quickly moving into the types of use cases, we've started to understand, of course, there are repeatable business patterns, which is the key component of the platform, to not have to recreate the same type or style of AI use cases, and we can start now bucketing them into automation and decision-making type. Here's one of the use cases we are working through, which is a conversational analytics. So it's basically looking at market signal, historical context from the marketing team, and it's using kind of dynamic dashboards to be able to generate the insights quicker to those stakeholders that need to consume it. Another use case also from the marketing team is the AI lab, which is basically looking at a full workflow from research of a particular vertical into the actual deployment of advertisement for some of our Sage products.
Business on a Page is aimed at our executive leadership team. It brings business metrics, market intelligence, and strategic insights into a single decision support surfaced within Nexus. And next on our roadmap, we've got Knowledge Graph, Tool Catalog, and Nexus Studio. Together, these will help us make agents more contextual, easier to build, and more reusable across teams and for our citizen developers. And takeaway here is simple, hopefully. Nexus is our repeatable path at Sage from AI idea to governed business outcome. It helps us to move faster, but with safety, monitoring, ownership needed for controlled AI at an enterprise scale.
Hi, everyone. I'm Obina, and I work on production AI at Rotok. I also run Wasabi Analytics, which is a data consultancy. And today I'll talk through what happens when you deploy RAG in a domain where a plausible wrong answer is worse than no answer. So this is the key design decision that drives everything. In some high-stake domains, a plausible wrong answer can have really high implications. So there are three main reasons why naive RAG systems break. The first one is messy sources. So you have inconsistent data formats. Some PDF documents can be scanned, some are text-based, OCR noise, layout drift, and then high stakes. You have decisions that are being taken on this. So in this domain, we are looking at UK corporate insolvency, and you have thousands of notices, you have thousands of filings. And one thing anyone would tell you in the insolvency space is no one gets paid for being almost right. You have little to no margins for errors. And what the experts need, they need evidence, not eloquence. So you could have results that sound plausible, but then there needs to be evidence and citations that are linked to the source of the results. So the key architectural decision that we made was to separate where we look. So basically, you have a discovery layer that gets the document. So we separated that. And then, so you separate where you look from what you trust. So most RAG systems, they collapse this into one. But then here you separate them and it gives you more accuracy and a better robust system. So you separate where you look from what you trust. So for this system, for corporate insolvencies, discovery layer is the Gazette's website, and its role is high recall discovery. And it answers questions like, did something happen? So basically, you can go there and find events that happen for different kinds of insolvencies. And this gives us candidates that are worth investigating. Then you have the authority layer, which is the company's house platform. And its role is authoritative extraction. And it answers questions like, what do we believe? So you source from the Gazette, and this gives you the evidence. So it gives us page-cited evidence. So Retriever tells us where to look, and then the authority layer tells us what evidence and what to believe with citations to the source. So for this pipeline, we have 5 stages. The first is the discovery stage. So this discovers high recall events. The next one is the ingestion stage, where you ingest immutable raw data. Then you have the process stage, that's page-aware extraction. Then we find evidence. So how we constrain the model, we have 3 guardrails. Evidence-based generation. So without no evidence, we don't return the answer. Then unverifiable rejection. So the fact that it's fluent doesn't mean it's accurate. We have to verify and reject those results. So basically, fluent is not correct. This is the key thing that when building RAG systems, you have to have in mind. The fact that you have fluent result doesn't mean that's accurate. You've got to have citations and evidence that backs it. So you've got 3 failure paths. The first one is when there's no evidence, we refuse the results. And then when there's low coverage, we have fallbacks to reacquire and enrich the data source. And when there's model failure, we have a deterministic fallback. So basically, a graceful refusal beats a fluent lie. So refusal is a feature, not a failure for the system. It's a design. You refuse results that don't have evidence. So a graceful refusal beats a fluent lie. So the key takeaways from this: first, discovery is not equal to authority. And then secondly, evidence is greater than eloquence. Thirdly, we refuse results when we are unsure, need to have evidence to back the results. And lastly, trust is engineered. So in summary, trustworthy RAG is a systems problem, not a model problem. So the key thing is the architecture and system you build around the model, not the model itself. The trust comes from the architecture, not the model. Thank you.
Hello, I'm Rebecca and I'm from Certara. And my talk today is a bit more of a personal perspective on what it was like becoming a software engineer when AI was kind of transforming the industry, and how our team's workflow have evolved over the past year. And so I don't come from a traditional software engineering background. I've recently finished my PhD, which was in environmental engineering, building machine learning models focused on water resource systems. I'm building a lot of data-driven tools, mainly with Python, R, and Shiny. So I joined Certara as a junior software engineer, and I was kind of thrown into modern Angular front-end code that I hadn't really touched before. And as you can imagine, being able to use AI and Cursor made it a lot easier to learn while also being able to contribute to production applications from basically day one. I want to touch on a project I've been working on recently, which is Codex. This is Certara's library of published clinical trial results. And the application is basically driven by a load of different flat Excel files from different indication databases. And the kind of goal here was to derive one consolidated relational schema. The scale was like we're looking at 80 different data sets for a specific disease indication, over 4 million rows, 3,000 unique columns across databases. And they all had kind of their own relationships, their own different naming consistencies, conventions, and data inconsistencies. Oh, very fast. So we kind of threw AI at this problem at the start. What we were able to achieve was really sped up. So with Cursor, we designed a kind of pipeline which analyzed relationships, automatically detected data quality, inconsistencies, and derived a combined schema, all with a kind of Shiny app that allowed you to review the decisions, validate output. Yeah, and the bottom line was this condensed what would have been like sort of weeks or months of trial and error into a pipeline that ran through 80 data sets in like less than a day. And what started as kind of an exploratory project, like can we do this with the data we have, grew into kind of an operational pipeline that required us to move from building fast to building a kind of reliable system. And what we needed for this was basically every decision needed to be traceable. So if we were transforming data, if we were excluding rows, we needed kind of logs for this. We needed documentation on why and how we were doing this. And it needed to be reproducible in that once we get new data, once data gets updated, the pipeline is capable of running with that. And at the same time, we were getting really frustrated with AI in that it ignores conventions it's never heard about, unsurprisingly. And we were getting a lot of data drift with just small changes. And it seemed like between a lot of back and forth conversation with AI, simple tasks were taking longer. So for us, it seemed like the challenge wasn't really writing code anymore. AI was good at that, but it more became about how you can govern how AI is writing that code. And we started designing a kind of environment where AI and humans are sharing the same workflow, the same requirements and verification process. We called this an AI native development model. So we basically built a set of files or governance layers which defined exactly our system requirements, constraints, what we were building. They're basically just markdown files. And the idea is that everything that matters, everything that's written down is enforced by some form of like enforcement layer. So Cursor rules enforcing behavior at the point of code creation, tests verifying each statement, and then a CI gate which will block anything that violates anything in your sort of contract. And yeah, this sounded kind of abstract at the start, but this diagram, I attempted to show how it looked whenever it comes to a feature request. But the main idea is you don't get AI to write code before you've properly defined all your constraints, all your rules in a contract. And that's where we spent most of our time at the minute, at writing these contracts and defining our exact assumptions. Anything that's in your head moves into some kind of machine readable format. And then from this, everything else, all the implementation tests can be derived. So when it comes to the implementation, we try to write the contracts in a way that you can send off to two separate agents who can independently, one can generate the code and one can generate the tests. So it is kind of that extra layer of independent testing to check that the output is what you expect. And then our governance layer is built in through all of our checks we've already gotten in place. Then by the time it gets to the review, all of our sort of enforcement layer have already been validated. So the job of the reviewer kind of changes from like, does this code work to like, is this what we need to build or design decisions? So yeah, your review kind of shifts up a level. Key takeaways. So I wanted to get into software engineering because I enjoyed coding, but with AI now, we're not really coding ourselves anymore, which kind of worried me a little bit. But I think over the past few months, it's kind of changed just to, rather than writing your usual code, it's like a different level or a different style of coding. And it forces you to think about the bigger picture. And we're still this is just kind of new for us. And we're still learning how best to write our contracts or best to use the tools we have. I think that's probably over 6 minutes. Thank you.
Morning, everyone. So my name is Will Kirby. I'm a senior environmental scientist at Wessex Water, and today I'm going to talk to you about how we're using ML to predict water quality at inland bathing waters, some of the challenges that come with working with environmental data, which is going to make the big data guys in the room weep, and how we've kind of mitigated for that. So there's been a big surge in wild swimming in the UK in recent years. In 2019, there was only 1 designated bathing water in the UK. Now there are 20. 4 of them are within our operational area, but a lot of these have been driven by the COVID-19 pandemic, people starting to swim in rivers. The way that they're monitored at the moment is a bit archaic. So someone has to take a water quality sample, they have to take it to a lab where it's plated up and incubated. That takes 48 hours to give you a result. And then by the time you get a result back, the bathers have already been exposed to the risk in the river. So we decided there's got to be a better way of doing this. So in 2021, we partnered with a company called Unify to try and produce a real-time alert system for bathers. We were using proxy parameters that could be measured by a real-time sensor and then make the predictions available in real time through a web app so that people can see them on the bank before they enter the water. So we're using water quality sensors that are measuring a range of parameters, but we're also ingesting data like storm overflow operation alarms, and then rainfall data that's coming from either the Met Office or the Environment Agency, and in-stream flow monitoring from the EA, and those are our predictors, and then mapping them to lab data. We put out our first model in 2022 that was providing predictions with an accuracy greater than 90% for fecal indicator organisms. This has been really well received by a range of stakeholders. We had a lot of interest in it, and obviously there's an ask to do more. So now in our current program, we are trying to roll this out to 20 sites by 2028. And, it's just that easy. Just scale it, do the same thing 20 more times. But if you could do it faster and for less money this time, that would be great. The problem is the environment's quite complicated. If you tried to characterize all the processes that are going on that slide in a meaningful way, it would be quite tricky. And it's quite naive to assume that just because it works that way at Whalley Weir, that you will be able to take the same model and transpose it to a different location. So really what I wanted to talk about today is some of the ways that we've gotten around that and the practices that we've implemented that have allowed us to create a scalable solution where we can ingest data from new sites and turn them around as quickly as possible. The first one is be really strict with your scope and try and keep it simple. So everyone's favorite agile principle, customer satisfaction, comes first, and keeping it simple don't always play well, but a simple solution is something that is going to be easier to execute, and it's much easier to test your performance metrics. So we've turned this into a classification task. We've taken the numeric values and created a flag, and then that is what we communicate. There is business value to us for a numeric output, but that's too much information really to provide someone who's looking at their phone on the bank. So it's just finding that balance. The other issue that we've had is data availability. So we're taking a sample about once a week. You're getting 1 labeled sample a week from these locations. There are constraints that mean you can't just throw money at the solution and take more samples. And also the data is really heavily biased towards good quality. Poor quality events are quite rare. We've resolved this by pooling the data. So we've produced a generalized model instead. That's allowed us to be a little bit more aggressive with our train test split. So we've got a larger pooled train set group, and then the test groups stay large enough that we can get some kind of meaningful performance metrics out of them. And then finally, obviously, these really small data sets are quite liable to domain shift, either new sites coming online or conditions like drought, exceptionally wet winters, like asset failures will cause deterioration in accuracy. So we've implemented a champion challenge setup where there are multiple models trained at any one time. All of them are continuously evaluated, and if the performance of one model starts to outcompete another, it gets swapped out. Retraining only occurs when all potential options no longer reach a threat threshold for accuracy. So to conclude, by implementing these, we've managed to produce a single set of pipelines that allow us to ingest data, train, test, predict, train, and retest where necessary to roll out 20 sites quite quickly. And then finally, just to finish up, I'd just like to acknowledge the amount of work that's gone in across a really large organization to roll this out. It's not just me as an environmental scientist. My colleagues, Sebasmit and Merin, who are here, have done an awful lot more work on the back end than I have. I'm just the person up here talking about it. Finally, if you scan that QR code there, it will take you through to our water quality live page, which is showing the real-time predictions. I tested it about 4 minutes ago. It was working 4 minutes ago. Don't blame me if it's broken now. And does anyone have any questions?